When we think about stars, we often picture those twinkling points of light scattered across the night sky. But have you ever stopped to consider how they compare to our very own sun? It's fascinating to dive into the differences and similarities between these celestial bodies. First off, let's talk size. Our sun is classified as a G-type main sequence star, or a G-dwarf star. It's about 1.4 million kilometers in diameter, which sounds enormous, right? But in the grand scheme of the universe, it's relatively average. Many stars out there are giants like Betelgeuse, which is about 1,000 times larger than our sun. Imagine that. If Betelgeuse were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. Now, let's consider brightness. The sun is the brightest object in our sky, providing the light and warmth necessary for life on Earth. However, stars like Sirius, the brightest star in our night sky, are much more luminous than the sun. Sirius is about 25 times more luminous, which is why it shines so brightly. It's interesting to note that the brightness we see from stars is not just about their inherent luminosity. Distance plays a huge role. Many stars we see are hundreds or even thousands of light years away, which diminishes their brightness by the time it reaches us. Temperature is another critical factor. The surface temperature of the sun is around 5,500 degrees Celsius. In contrast, some stars, like the blue supergiants, can reach temperatures exceeding 30,000 degrees Celsius. These extreme temperatures contribute to their vibrant blue color, while cooler stars, like red dwarfs, can be as low as 3,000 degrees Celsius. The color of a star tells us a lot about its temperature and age. Speaking of age, the life cycle of stars is a captivating topic. Our sun is about 4.6 billion years old and is expected to continue shining for another 5 billion years before it exhausts its nuclear fuel and expands into a red giant. In contrast, massive stars live fast and die young, often exploding in spectacular supernovae after just a few million years. This explosive end can create neutron stars or black holes, while smaller stars like our sun will eventually shed their outer layers and leave behind a white dwarf. Let's not forget about composition. The sun is primarily made up of hydrogen and helium, with trace amounts of heavier elements. Many stars share this composition, but others, especially older stars, can have a higher concentration of heavier elements, which can tell us about the history of the universe and the processes that formed these stars. In summary, while our sun is a remarkable star that supports life on Earth, it's just one of countless stars in the universe, each with its own unique characteristics. From size and brightness to temperature and life cycle, the comparison between our sun and other stars reveals the incredible diversity of the cosmos. Each star tells a story, and understanding these differences helps us appreciate the vastness of space and our place within it.